We cloned a YOLO version 3 model. So and the way that we just did that was you went to neural nets, clicked on add, select version 3 YOLO model, clicked on add, then it will ask you a name. You just give it as dog detector um, underscore YOLO and click on clone. So once you are done with that, so you got this model object here. You can train that. So the way that you train is you select which data set that you want to use for training. So in this case, you have to use the one that is classified into train and validation data set. And which model, that's a dog detector YOLO. And then in the configuration, you have to change some of the parameters. I would give, say, um, yeah, 100 epochs and training data set batch size is 6. And that's pretty much it is. And you have to give a name for the output of this model. So let's call it as dog detector model. Okay, click on run. So now it's pretty much running this on my GPU machine, which is called as Flabby Guile, which is not the name that I chose, but it's given like that. So and you can monitor the progress, the checkpoints, because for all the 100 epochs, it creates one checkpoint for every epoch. So having a machine with a good amount of disk space is important for you to train this. Or you can also purchase some of this computing storage power from cloud, okay, if you don't have a local machine. So essentially you can click on this train graph to see what is the loss over a period of over the set of epochs. And once it is done with that, you just have to pick the one which has a even number epoch, and the loss is probably the lowest. Okay, so we'll let this go on. So now it is at 0.34, 0.5, 0.5, 0.25. So, and since we only have 61 images, that's also another thing. So we should probably do data augmentation to make this better. So let's see what would be the result without doing data augmentation. Then we'll do the same with data augmentation. So 0.25. So you can also change the starting point. So since okay, the 20 epochs is okay, now you want to see what is, if you want to pick the lowest. So 39th epochs, 40th epoch seems to be better. I think that seems to be the lowest so far, with 0.09 as a loss. And let it go on for some more time. Yeah, I think in most of the cases I've seen 35 to 50 epochs is a good number. Okay, I don't think we should really bother after this. I think 40 is a good number. I've seen it goes up to sometimes, like depending on your training data set, can go up to like 0.05, 0.06 also. But yeah, not good, not good. Yeah, I think we're going to settle with the 40th epoch. I think that looks so far the best one. Uh, you just like in case of supervisory, they create for some reasons some epochs with a fraction value like 63.1234, something like that. So you don't really need to. Okay, so this is 0.07, 0.09, 0.07. So maybe I'll do this from 40. So now if you want to see how my GPU is performing at this time, um, I can connect to my GPU, and then I can see, okay, NVIDIA SMI, you can see it's pretty much not utilized much because it's pretty much done here. Okay, I should have shown you at the time. You will be able to see the utilization going up when you are training the model. So okay, with that, I think we're going to use 0.13.07. Yeah, I don't want to do any war fitting kind of things, so I would go. I can probably try with this 89 epochs or 95, 18, let's see, from okay, this is 100 is 0.06. Okay, so I'm going to use the 100th one to see how it looks. Means just to test it out. Okay, let's see how it works. So now what we do is we yeah, train the model. The model is trained, and it is uploading the weights um, back from the machine where it actually processed to the server. And once it is done, then you can start creating the model. So actually I think we can do that right now. I would let it finish whatever it is doing, then I will do that.